Adding another 200 amp panel off the existing 320 amp service is not allowed according to the National Electrical Code, or NEC. Article 225.30 states that the maximum number of circuit breakers that shall be installed in an enclosure shall be determined from the available space with a minimum clearance between adjacent circuit breakers as required by 408.3d. Article 408.3d specifies where circuit breaker handles are in a vertical position, the handles of circuit breaker shall not be less than 2 inches apart. In this case, since the two existing 200 amp panels are already completely full, there is no available space for a third 200 amp panel. Therefore, it is not possible to meet the minimum clearance requirements of Article 408.3d. Instead of adding another 200 amp panel, there are some viable alternatives that can be considered. Firstly, you could increase the size of the service entrance. Consider upgrading the service entrance from 320 amps to 400 amps or higher. This would provide sufficient power for the additional circuit breakers needed. Secondly, consider installing a subpanel. A subpanel can be installed within one of the existing 200 amp panels. This allows for the addition of more circuits without exceeding the capacity of the main panel. Thirdly, explore the use of a load management system. Implementing a load management system can prioritize electricity usage and prevent overloads. This approach would enable the use of all available power without exceeding the service entrance capacity. Remember that any changes to the electrical system must be performed by a qualified electrician and must adhere to all applicable code requirements. When dealing with electrical systems, safety and compliance with regulations are paramount. Before making any modifications or additions to your electrical setup, it's crucial to consult with a licensed electrician who can assess your specific needs and ensure that all work is done safely and in accordance with local codes. Electrical codes like the NEC are in place to protect people and property from hazards such as electrical shocks, fires, and equipment damage. Failure to comply with these codes can have serious consequences, including fines, legal liabilities, and increased risk of accidents. One key aspect of electrical work is proper load calculation. This involves determining the total electrical load that a system will be subjected to and ensuring that the wiring, circuit breakers, and other components are adequately sized to handle that load. Overloading a circuit can cause wires to overheat, potentially leading to a fire. In the scenario described, where there is a desire to add more circuits to an already full electrical panel, it's especially important to conduct a thorough load calculation. This calculation should take into account all of the appliances, lighting fixtures, and other electrical devices that will be connected to the system. By understanding the total load, you can determine whether the existing service entrance and panel capacity are sufficient or if upgrades are needed. When considering an upgrade to the service entrance, you'll need to factor in the cost of new equipment, such as a larger meter box, service panel, and wiring. You may also need to obtain permits from your local building department and arrange for an inspection to ensure that the work meets code requirements. The cost of an upgrade can vary depending on the size of the service, the complexity of the installation, and the local labor rates. Installing a subpanel can be a cost-effective way to add more circuits without upgrading the entire service entrance. A subpanel is essentially a smaller electrical panel that is fed from one of the existing circuit breakers in the main panel. This allows you to create a dedicated circuit for a specific area or appliance. When installing a subpanel, it's important to choose a location that is easily accessible and has enough space for the panel and wiring. You'll also need to ensure that the subpanel is properly grounded and that all wiring connections are secure. Load management systems are designed to monitor and control the electrical load in a building. These systems can automatically shed loads during peak demand periods to prevent overloads and reduce energy costs. Load management systems typically consist of a central controller, sensors, and relays that switch circuits on and off as needed. These systems can be programmed to prioritize certain loads, such as critical equipment or life safety systems, and to shed non-essential loads, such as lighting or air conditioning, during peak demand. When choosing a load management system, it's important to select a system that is compatible with your existing electrical equipment and that meets your specific needs. You'll also want to consider the cost of the system, the ease of installation and programming, and the level of support provided by the manufacturer. In addition to the alternatives discussed above, there are other strategies you can use to reduce your electrical load. These include using energy-efficient appliances and lighting, turning off lights and appliances when they are not in use, and reducing your use of high-energy devices during peak demand periods. By implementing these strategies, you can lower your energy bills, reduce your carbon footprint, and help to prevent overloads on your electrical system. Always consult with a qualified electrician before making any changes to your electrical system. An electrician can help you assess your needs, recommend the best solutions, and ensure that all work is done safely and in accordance with code requirements. Remember that electricity is a powerful force and that working with it can be dangerous. Never attempt to perform electrical work unless you are properly trained and qualified. If you're not sure how to do something, it's always best to call a professional. Electrical safety is not just about protecting yourself, it's also about protecting your family, your property, and your community. By following the NEC and taking precautions when working with electricity, you can help to prevent accidents and ensure that your electrical system is safe and reliable. To recap, when faced with a situation where an electrical panel is full and additional circuits are needed, it's crucial to avoid simply adding another panel without proper consideration for the NEC and the overall load on the electrical system. The NEC prohibits adding a third 200 amp panel to a 320 amp service without careful evaluation and adherence to specific requirements. The code addresses issues like available space within enclosures and minimum clearance between circuit breakers, ensuring safety and preventing overcrowding. Instead of bypassing these guidelines, explore viable alternatives that comply with regulations and address the underlying issue of insufficient capacity. Firstly, consider upgrading the service entrance to increase the overall amperage available. This may involve replacing the meter box, service panel, and associated wiring to accommodate a high capacity. Secondly, explore the option of installing a subpanel within one of the existing 200 amp panels. This allows for the addition of more circuits without exceeding the capacity of the main panel. Thirdly, investigate the use of a load management system to prioritize electricity usage and prevent overloads. This can help maximize the use of available power without exceeding the service entrance capacity. When evaluating these alternatives, it's imperative to conduct a thorough load calculation to determine the total electrical load of the building. This calculation should account for all appliances, lighting fixtures, and other electrical devices that will be connected to the system. Proper load calculation ensures that the electrical system is adequately sized to handle the demand, preventing overloads and potential hazards. Furthermore, any changes to the electrical system must be performed by a qualified electrician who is knowledgeable about the NEC and local code requirements. An electrician can assess the specific needs of the building, recommend the most appropriate solutions, and ensure that all work is done safely and in compliance with regulations. Remember that electrical work can be dangerous, and it's essential to prioritize safety at all times. Never attempt to perform electrical work unless you are properly trained and qualified. Consulting with a professional electrician is always the best course of action to ensure the safety and reliability of the electrical system. In conclusion, adding a third 200 amp panel to a 320 amp service without proper evaluation and adherence to the NEC is not a recommended or compliant solution. Instead, explore alternatives such as upgrading the service entrance, installing a subpanel, or using a load management system. Always prioritize safety and consult with a qualified electrician to ensure that all work is done in accordance with code requirements. By following these guidelines, you can ensure a safe and reliable electrical system for the building. The National Electrical Code, or NEC, serves as a comprehensive set of standards for electrical installations in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It is designed to protect people and property from electrical hazards and to ensure that electrical systems are installed in a safe and reliable manner. Compliance with the NEC is essential for all electrical work, and it is the responsibility of electricians and other electrical professionals to be familiar with its requirements. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical work is compliant and safe. In addition to the NEC, there may be local electrical codes and regulations that apply to your area. These codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to be aware of and comply with all applicable codes and regulations when performing electrical work. Failure to comply with electrical codes can result in fines, legal liabilities, and increased risk of accidents. It is always best to consult with a qualified electrician or building inspector if you have any questions about electrical codes or regulations. They can provide guidance and ensure that your electrical work is compliant and safe. The information provided is intended for general informational purposes only and does not constitute professional advice. Electrical work can be dangerous and should only be performed by qualified and licensed professionals. Always consult with a qualified electrician or building inspector before making any changes to your electrical system.